An empty vector is a vector that has no elements in it. You can create an empty vector by using square brackets with nothing inside. Empty vectors can be used for a couple of things. One is to delete an element from a vector. What you do is you assign an empty vector to that particular element, and it will delete that element from the vector. To delete an entire row or a column from a matrix, you can also accomplish by assigning the empty vector. But note that you can't delete an individual element from a matrix, because if you do that, then you don't have the same number of values in every row in the matrix, and that always has to be the case. So again, for a vector, you can delete an individual element. For a matrix, you could delete an entire row or an entire column, and both would be accomplished by assigning the empty vector. Another way in which you can use an empty vector is to grow a vector. So basically you start with nothing, you start with an empty vector, and then you keep adding more and more values to the vector by concatenating them. Usually that's done in a loop, which will be covered later. This is actually not very efficient, however, and it should be avoided if possible. MATLAB can have three-dimensional matrices. A three-dimensional matrix has dimensions m by n by p. So imagine a two-dimensional matrix that has dimensions m by n, and then imagine layers of that. So for example, if you had a 3 by 5 by 2 matrix, then you would have two different layers in which each is a 3 by 5 matrix. There are many ways that you can create a three-dimensional matrix. For example, we could do that using the randi function. So we can create a three-dimensional matrix of random integers. Here's an example in which we have random integers in the range from 0 to 50, and we're creating a 3 by 5 by 2 matrix. So that gives us basically two layers in which each layer is 3 by 5. When we use the randi function to create this three-dimensional matrix, it shows the individual layers. So it shows ants, since we didn't assign this matrix to any variable, it uses ants. And it shows that the first layer is a 3 by 5 matrix, and then it shows the second layer is another 3 by 5 matrix, again in which each element is a random integer in the range from 0 to 50. The function diff is a really useful function. What it does is it returns the differences between consecutive elements in a vector. So here's a vector vec that has 5 elements in it, 6, 2, 9, 11, 33. If we use the diff function, what we're doing is we're getting the difference between consecutive elements. So in other words, 2 minus 6 gives us negative 4, 9 minus 2 gives us 7, 11 minus 9 gives us 2, and 33 minus 11 gives us 22. So in this case, we have a vector that has 5 elements. The difference vector is going to have 4 elements. So in general, if a vector has n elements, think about this. How many elements would diff of vec have? The mesh grid function is a very useful function also. What it does is it receives as input arguments two vectors, and it returns as output arguments two matrices that specify separately x and y values. For example, if you wanted to create points in which x has the values 1 to 3 and y has the values 1 to 2, in other words, the points 1, 1, 2, 1, 3, 1, 1, 2, 2, 2, 3, 2. So again, the x coordinates range from 1 to 3, and the y coordinates range from 1 to 2. The mesh grid function can accomplish that for us. So we pass to the mesh grid function the range that we want for the x coordinates, 1 to 3, and then the range that we want for the y coordinates, 1 to 2, and it's going to return two separate matrices. So since the function returns two things, we want to put the call to the function in an assignment statement that has two variables on the left. So x is going to store the first matrix, and y is going to store the second matrix. So if you compare the x and y matrices with the points, in the first row we have 1, 1, and then 2, 1, and then 3, 1. And in the second row we have 1, 2, and then 2, 2, and then 3, 2.